Hello and welcome back to Precalculus. The lecture for today is on hyperbola, and I already have the basics here listed. Both of these hyperbolas are centered at the origin, and you have the horizontal hyperbola and vertical hyperbola with their respective formulas. Hyperbola is used in describing the path of the, let's say, asteroids. It could have hyperbolic trajectory, but then also hyperbola is used in a lot of other applications, including, as you can see over here, satellite dishes and a whole bunch of optics and a lot of other places. Now, satellite dish is a really good use of this hyperbola because incoming rays of whatever sort they bounce off of the hyperbolic surface into the receptor, which is placed at the focal point of the ellipse. So that way, the focal point of the ellipse gives you the a point, right, a location where all of those would converge into a point. All of the rays that come in bounce into a focal point. Now, there are two focal points, one on the left and one on the right. We can call them F1 and F2. And we had that location A, right, which was the location which separates the vertices from the center of the hyperbola. Now, you might ask, well, what about B? What is B doing? Well, B will be used to calculate in the formula that we are going to see a little bit later, to calculate the value C, which is the value that you need to figure out where the focal point is. So we will do those calculations, but let's first focus on the basic formula for the hyperbola centered at the origin, and then let's graph a hyperbola that is at the center and then shift it right to whatever, left, right, up, down, and then take a look at that as well. So let's say graph a hyperbola of y squared over 16 minus x squared over 9 equals to 1. So if this is hyperbola given, your first job is to figure out whether hyperbola is horizontal or vertical. So if it's x squared minus y squared, it's horizontal. And if it's y squared minus x squared, then it is vertical. So in our case, we have y squared minus x squared, which means that we are going to have a vertical hyperbola. And since there are no values subtracted or added to x and y, that means that the hyperbola will also be centered at 0, 0. So that's our 0, 0 there. And we have to go 4 units up and 4 units down. Again, 16 can be written as 4 squared, and then 4 is associated with y. So we'll have to go 1, 2, 3, 4 units up, 1, 2, 3, 4 units down. So that's 4, that's negative 4. And from there, we draw hyperbola. Now, as long as you draw hyperbola, decent, we're good to go. Now, as you can see, we did not use 9. And the 9, as I said, will be used in conjunction with, in a formula to calculate C, which will eventually give you the location of the focal points F1 and F2. Let's take a look at the shifted graph, a parabola given by x minus 3 squared over 25 minus y plus 1 squared over 9 is equal to 1. So now in this case, we have x minus 3, which means 3 to the right. And so 3 to the right, meaning the the hyperbola would move 3 units to the right from the origin. And then we have y plus 1. Now, plus 1 in this case means it goes down. The motions are opposites for what you would like them to be. So the formula is x minus h and y plus k, the same like for ellipse. And this one is going to go 1 down. So how do we know this? As I said, we have x minus h squared over a squared minus y minus k squared over b squared equals to 1. So now when you compare this, you will get that h is equal to positive 3, and you will have that k, which is associated with y, k is equal to negative 1, because the signs don't match. When the signs match, you take the same value, so positive 3 and negative 1. So you have 3, negative 1 as the center. And if your old center was at 0, 0, you are supposed to go 3 units to the right, 1 unit down. And that would be the center. So we're going to draw our coordinate system first. And then we're going to go 3 units to the right and 1 unit down. So this is where 3, negative 1 is, and that is where the center of the hyperbola is. Now that creates this line that I'm going to erase later. That creates the new line on which you are supposed to draw your hyperbola. And on that line, you have to go 5 units left and right, because 25 is associated with x. So, and we know it's a 25 should be 5 squared. So we're going to go to the center point. We're going to go 5 units to the left and 5 units to the right, because it is the horizontal hyperbola. 2, 3, 4, 5. Here's one of the vertex. 2, 3, 4, 5. Here's the other one. And we draw hyperbola through those two points. Now, labeling these points obviously for the exam, that has to be 8, negative 1. You're not labeling it for the exam. No one cares about the exam. You're labeling it, because someone else needs to read your graph, whether they're making the glasses or designing a satellite dish or something. So that's the reason why we do all of this. So that will be a negative 2, negative 1 in this case. So those are the vertices, right? You have your x and a y. And as you can see, this hyperbola is not centered at 0, 0. It's centered at 3, negative 1. So this information is picked up from the equation given to us. And we can immediately pick up, if you just use opposite signs, right? You can immediately pick up the center, which opposite signs, right? Negative 3, now it's 3, and positive 1, now it's negative 1. And if you use those, you have your center. Then once you have the center, you need to know whether the hyperbola is horizontal or vertical, and that is that x minus y, so it is horizontal hyperbola. Then how far is each vertex, how far is it away, or are they away from the center? And the answer is 5, because 5 squared is 25. So that's why I counted 5 on either side. And now I can get rid of this blue line. I don't need the blue line. You know, the hyperbola is there, and we're done with that line. The line is just there to help us line everything appropriately. Now, there are things that you can do to make your to make hyperbola graph nicely, and we're going to learn about these lines and the rectangle, which are called well, the lines are called the asymptotes of the hyperbola, because the hyperbola will follow these asymptotes into infinity. So let's take a look at again basic case, and then better, because these are sketches. They're good, but they are far from perfect because we did not use any guidelines. And this is where also that story with the ellipse that I mentioned will kick in as well. So let's graph. I'm going to jump in the homework, and or maybe this one looks good. X minus 3 squared over 4 minus y minus 1 squared over 1 equals to 1. And I don't like that they put this, just put y minus 1 squared. And a reader should know at this point in a game that it's divided by 1, because there's nothing there. Anyway, we know where the center is, right? Center is at 3, 1. Because both of the parentheses have negative signs, our formula has negative signs. It's x minus h and and y minus k. So when x is matched and minus matched, then the h is just 3, and then later k is just 1. We're also dealing with the horizontal, but you know what? Here is the really cool way of dealing with all of this. We're going to, again, the ice pack, the bane of my existence, right? Can't draw anything straight. Constantly rocking on this. All right. So now I'm going to put the center, which is 3, 1. And we are going to go 2 units to the left and 2 units to the right. That's because 4 is 2 squared. But on the other side, you have a 1 squared. Now, we haven't used this one before, and now is the time. 1 is associated with y, so we'll go 1 unit up and down. Hey, this is exactly all you need to draw your ellipse, right? But instead of drawing the ellipse, this time you're going to draw lightly. You're going to draw this rectangle going through all of these points. And the reason why we need that rectangle is that the corners of the rectangle will give us the asymptotes that hyperbola is going to follow. So I'm going to draw, maybe you can do blue. We're going to connect the corners and go to the other side as well. It goes through this point, this point, this point. Okay, so that's that side. And now the other side, I'm going to again draw these dots that help with orienting everything. So now how do I know that I'm supposed to put the dots there? Well, you have the dot from the center to the corner. You see, you go 2 and then 1 up. So 2, 1 up, 2, 1 up, and so on. On the other side, it's 2, 1 down, 2, 1 down, and so on. So that's how I know where these points go, so that I can nicely draw this, right, hitting through those points. These are my asymptotes. And now you can draw the hyperbola here and here or on the side. Where do you draw your hyperbola? Well, it's x squared minus y squared. So these are sideways parabola. Now you have your vertex, sideways hyperbolas. So you follow these asymptotes into infinity. So that's the proper way, right, when you deal with asymptotes. And then we have one more thing, and then this is the graphing story is done. And that is that you can find the equations of these asymptotes if you want to, right? So that's another thing. And for graphing, that ellipse, which I mentioned earlier, if this was a plus, would fit exactly inside this box. Because you can see that your ellipse has 2 on a major radius and 1 on a minor radius going into the y direction in this case. So you will have horizontal ellipse over here, and because of that, the function is horizontal. The hyperbola is the horizontal, because the ellipse was horizontal. When ellipse is vertical, your hyperbola is vertical as well. They go hand in hand, and all you're doing is changing this one sign. You're changing one sign, and that's what you have. Let's take a look at the calculation for the focal point, and then we're done with the basics. We can start working out some of the homework exercises. So for the focal point, right, remember what you have. You have x minus h squared over a squared minus y minus k squared over b squared equals to 1. So when you have this situation, you have sideways, right, the horizontal hyperbola. And we said that the point inside, the focal point f1, and we know that this much over here is a. So that's what we have for our values that we covered so far. So now the job is to figure out the value c, which will help you determine the focal distance, and that c is right there. So for focal point 2 over here, have a, and then you have again this value of c. Now c is given as a Pythagorean theorem, where c squared is equal to a squared plus b squared. Foci, that's plural because you always have 2 of them. So let's take a look at this calculation now and have the graph with not just vertices this time, but also the focal point. And I'm for this going to jump into homework and pick up one of these equations that you guys have. Here's a good one, 22. It says 4x squared minus 25, it's a terrible 5, 25y squared equals to 100. Now, does this look like equation for hyperbola? And the answer is hell no, because this has to be 1, right? You have to have 1 on that side. So to achieve that, you will divide everywhere by 100, and that way the 100 on the right-hand side will cancel, giving you 1 as the answer. So now 4 and 100 cancel. You get x squared over 25 minus, and now 25 and this cancels, you get y squared over 4 equals to 1. And now this looks like equation for hyperbola 100%. Now, it's a nice one, right? It's centered at the origin, so that's good. But we still have to figure out everything else. Now, remember what we said. We're going to, because it's the origin, right? So we're going to start by counting 5 left and right, because 25 is associated with x squared. Therefore, x squared, right, which is the x-axis. So we're counting 25, 5 each way, square root of 25. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And -5, I mean. Now we need to go up and down 2 units because the next one is 4, right? And 2 squared is 4. So now we're going to have this box, remember, where the hyperbola is on the outside of the box, and if you change the minus into a plus, you get the ellipse that it's inside the box. Now we have also learned that we are supposed to have these slant asymptotes. This is terrible. Somewhat better. So we know that the hyperbola is going to be this way, and the reason we know that is because it's x squared first rather than y squared. When it's y squared first, then you get this one. It's x, you get that one. This, at one point, students said this looks like an x because there are people that write x this way. Perfectly fine. I mean, it's stylish, it's nice in regards to the x I use. But you can maybe remember that, have the left and right with this one. Anyway, we have a graph. The only thing I want to do now is figure out the focal point. So A is equal to 5, B is equal to 2, and what is C equal to? Well, C is equal to square root of 5 squared plus 4 squared, which is square root of 25 plus 16, which is the square root of 41. So if you paid attention earlier, you would know that your focal point 1 over here is -5 minus square root of 41. So F1 would be okay. So we're going to have our focal point is going to be -5 units and then take away root 41. So -5 take away root 41 and then 0 because it's a point. You need x comma y. So now why is the x coordinate -5 minus root 41? Because from the center to -5 you have your a value, which is 5, but we have to put -5 because it's -5 on the graph. And then you need to, since this is negative, you need to subtract square root of 41 so they can add together and have this larger negative number. So -5 minus root 14 comma 0 is a point, is a location. Now, if you love your decimals, right, we are going to find -5 minus, hold on, my calculator. It's actually my fat fingers on the keyboard of the calculator. Okay, so -5 minus the square root of 41 will give us -11.4. So the focal point is at the negative 11.4. That doesn't look like what we have here on the picture, but that's okay. Now, the other focal point, f2 on the other side, is going to be 5 plus square root of 141 colon 0, which would give us 11.4 on that side. Now, obviously, it's going to be symmetric, right, because it's centered at the origin. Our next problem is going to be shifted, so the focal points are not going to be that easy to find, right? We'll have to compute. So we have the two focal points, and we have two vertices. We have the center at 0, 0. And if you want to, you can find the equations of the asymptotes. I believe that a couple of your homework problems will have you compute the value of these asymptotes. And actually, let's do it here because we can, and then move to the next problem. So for the asymptote, if you take a look, pick any one of them. Let's call this L1 and L2, line 1, line 2. Those are asymptotes. If you pick L1, note that it goes through this point here and the origin, right? The origin is 0, 0. And this point here is negative 5, negative 2. So you can run your algebra equation, or you can just count, right? If I want to get from negative 5, negative 2 to 0, 0, right, I have to go 5 units out, 2 units up. If I go 5 units to the right and 2 units up, I have, but now the slope is automatically change in y is 2, change in x is 5, so 2 divided by 5 would be the slope. But let's calculate that. So for the asymptote, I have negative 5, negative 2, and 0, 0 as points. So now, nothing else exists. We just have 2 points, find the equation of the line. You know that your slope, m, was given as y2 minus y1 over x2 minus x1. And you can call each one of these whatever you like, x1, y1, or whatever. So I'm going to put this as my x2, y2, and then this to be as my x1, y1. So the slope m is going to be y2, which is negative 2 minus 0 over negative 5 minus 0, and the slope is 2/5. It's an increasing slope. That's good for our line 1. As you can see up here, line 1 has the positive slope. So there is that part. And now when I have the slope and I have the point over here, I can come up with y equal mx plus b. Y is negative 2. M is 2/5. X 2/5, and what's x? So y, x is negative 5, good. And then plus that value b that you need for your linear equations. So 5 and 5 will cancel, so negative 2 is equal to negative 2 plus b, right? And you see that b is equal to... Now, y-intercept was supposed to be 0, obviously, because the equation goes through the 0. But now you have one more verification that that's good. So your slope, your equation for the asymptote, oblique asymptote, is 2/5 x. That's it. Now the other one has a different opposite sign. You should still compute it. But the other one, the other asymptote, the L2 asymptote for our picture, should have the same formula with a different sign. So what makes these problems interesting? Right? If it's nothing special, pretty much same as ellipse, we just have that C calculation for focal points as a little bit of an extra. But what is the big deal here, right? What are the non-easy problems look like? Well, just like with the ellipse, right? We can have annoying problems where you have to do completing the square, right? So we did review this last class, but now we need it again. And the way you compute, well, let's first put the problem down, and then, you know how I like to write, get all, all right? And the problem is, doesn't really matter which one you pick here, 46 is fine. Get all, then graph. So 9y squared minus 4x squared minus 18y plus 24x minus 63 equal to 0. One more time. 9y squared minus 4x squared minus 18x plus 24x minus 63. Cool. So we got all of that done and covered. So now let's go and deal with all of these. So we start by grouping y, 9y squared minus 18y. And then we factor out negative to have 4x squared minus 24x. And then I'm just going to ship 63 onto the other side, so it's not annoying in a way. Please note that for x terms, I factor negative sign because I am aiming for hyperbola equation. All right, cool beans. Have this, we have this, we have this. And now we factor out 9. We get y squared minus 2y. And we factor out 4, which gives us x squared minus 6x equals to 63. Now, for the first parenthesis, put a little star there, we have 2 divided by 2 squared, which is 1. And for the blue, we have 6 divided by 2, which is 3, squared is 9. So, we are going to add and subtract these values inside parenthesis. So as you can see, I'm working on 2 of these simultaneously, right? Gotta add 9, subtract 9. So you have to pay attention. They're completely different problems. So the first 3 will give you the completed square. Y minus 1 squared, there's a 9 in front. Minus 4, open parenthesis, again, we look only... Oh, I forgot to bring this one out. Minus 9, because this 9 in front distributes to all 4 members. Now, 3 of those members were mushed into this compressed, right? Into this one expression here, and it's still multiplied by 9. So these, the 3 that ended up in a parenthesis, the first 3 over here, those are still multiplied by 9. That's all good. See, the problem is that this last one over here, which is not a part of our completing the square, needs to be multiplied by the number in front, because number in front needs to distribute on all of them. So when I copy 9, I compress this, and then this negative one needs to be multiplied by 9, gives me negative 9. Now, for 4, I have x squared minus 3 x minus 3 squared. There we go. And then I have plus 36 equals to 63. Again, you have a negative 4 over here. You have a negative 9 over here. Negative 4 times negative 9 is positive 36. So now I have to deal with these constants first, and then we'll see, hopefully we get something nice. 9 y minus 1 squared minus 4 x minus 3 squared, and then plus 27 equals to 63. So 9y minus 1 squared minus 4 x minus 3 squared is equal to, when you take away 27, you get 30. You take away 27, so what is that? 36. 36. When you subtract 27 on both sides. Cool. Now we know that we need 1 over here. Let me write that in blood. And that's the step that prompts you to divide everywhere by 36, because the only way to make that 1 there is to, whatever number is up there, you divide it by itself, right? Divide both sides by itself, by that number, to give you the 1, which you need. But now 9 and 36 will cancel into y minus 1 squared over 4. Minus 4 and 36 will cancel to give us x minus 3 squared over 9 equals to 1. And finally, I have the equation of the ellipse. Can this be more complicated? Can this be more annoying? That's the right word to use. And the answer is obviously yes, right? We can toss in fractions and all other stuff to make the life interesting. Anyway, we are going to take a look at the hyperbola we get in this problem. We do have center, right? Just by looking at it, you know it's 1, 3. And then we have that our a, which is associated with the first here, with the y. So a is equal to 2 and b is equal to 3. Now you can immediately go and calculate foci, right? So that's going to be c squared is equal to square root of a squared plus b squared. That's 9 plus 4. 9 plus 4 is 13. So it is the, I don't need the c squared if I'm going to have a root. It's the square root of 13. So one more time, 4 plus 9. 4 plus 9 is 13. Okay. So what do I have? Let's draw everything. We're going to include the asymptotes again, because why not, right? The center is at 1, 3. So this is where 1 is. 1, 2, 3. That's where the center of our problem is. If you want to, you can draw the new coordinate system that will be used a lot later. So these lines represent like the new coordinate system. Now I need to go 2 units left and right. So 2 units to the right, 2 units to the left, and then we need to go 3 units up and 3 units down, because those are b's. 3 units up, 1, 2, 3, and 3 units down, 1, 2, 3. Now, you might be tempted to draw the ellipse. You might be tempted to draw your hyperbola, but hold on. the first thing you should do is draw that box, the box that bounds your answer. So here we go, that's the box, and then on the other side, and here, there we go. So that's the box that is going to house an ellipse if you had to put a plus there. But we don't care about the ellipse now. What we care about are these asymptotes. And because we have y, we have to use top and bottom as our hyperbola answer. Focal points, and we are done. Please note that your focal points, right, they're x values, so you can just add and subtract again from the center point. So center point will have the x coordinate to be 1. So let's go, center point has the x coordinate to be 1. And then all I need to do is to, for foci, right, focal points, all I need to do is to say x equals 1 plus or minus square root of 13. That's all we do. So what is the equation now? We have two focal points. This is 1 plus root 13. No, lies. I did it wrong. I am adding them to x. So having a focal point does nothing here because there is no hyperbola to surround it. So I was supposed to add and subtract this on a y-axis. Not sure why I erased this. The center is at 1, 1, 3. So since we are starting at 3, my center is 1, 3. So everything happens on this elevation. No, lies. Everything happens according to this, which is, okay, showing the middle here. All right, so let's go and calculate the rest, which are these asymptotes and so on. So for asymptotes, you have a point here, asymptotes. We have the center at 1, 3, so y is equal to 3. That's the way we're looking at the problem, right? Up and down. So y is equal to 3. And what else do we need? Nothing. We can just compute now. We don't know, I mean, if you're careful enough, you can tell from picture, but we don't know where the focal points are. We know they're on this middle line that contains the vertex, it contains the center focal points, right? So they're all on the same line. And I already have that sees root 13. So, but I never wrote this. I'm jumping, okay. So focal points are x coordinate is 1 and the y coordinate is 3 plus or minus root 13. There you go, focal points. And now we can focus on asymptotes. What I wanted to do on asymptotes is do the full calculation for them because we have the numbers. This is the center, which is 1, 3. And I need to know what this point is, because I just need 2 points, and the rest will all follow. Now, that point has the coordinate from this point, x coordinate from this point, and that coordinate is 4. And then that point up there has the coordinate of the vertex, and the vertex was 4 units away, no, sorry, 3 units away from the,
Professor, I have a
yes,
question.
go ahead.
Wouldn't the hyperbola be from y equals to 1, not 0? Because that's like plus 2 and minus 2 from the center.
But you have to measure the distances. Let me see. Maybe I made a mistake, but let me just put this coordinate here. So that's a 3, 4, 5, 6. So that's a 4, 6, and now I can go and calculate asymptotes. And asymptotes are going to be done in orange. Let me take a look, just in case that there was a mistake. Why is this not changing color? Okay, fine, you win. Asymptotes. So when we draw, I can get rid of these extra lines that we don't need for now. You get your center from the agent K, and that was our 1, 3. So that was good, because we look at this location and this location, and oh, it's not 1, 3, it's 3, 1. It's 3, 1, because the Y was first. So it's 3, 1. Okay, so definitely there is a mistake. It is supposed to be 3, 1. So I have to redo the whole graph. It's okay. I'll do it again properly this time. The y coordinate. So thank you. Yes, thank you for speaking up, guys. X coordinate is here, and it's x minus age. So age is 3. So that's age. And then k is 1, which was 1. All right. So let's try this graph again. Hopefully better and correct this time. I completely missed that I did this backwards. All right, so we have 3 on x and 1 on y, and that's our center 3, 1. Now, 1 is associated, y is associated with 2, right? That's a 2 squared. So y will go 2 units up and down. 1, 2. I'll get rid of this 3. And the x direction is 3 units left and right. It's 1, 2, 3, 1, 2, 3. There we go. Much better. So now, when you complete your box, now I'll go orange to match because asymptotes. We need to complete this box. And now use these corner points to draw asymptotes through those points. And then the other side, I'm gonna make sure. There they are. And because it's the y squared first, from the vertex here, we are going to go and follow the asymptote out, and the same thing happens on the bottom. It's terrible, but The tablet is rocking. I can't do anything about this now. We need to be back in the classroom. And the focal points, well, now this is all backwards, so I have to fix all of this as well. Luckily, this stays the same, so it's a root 13 still. My center is 3, 1. That's the red point. And now, focal points are going to be on this line because they have to be included right there so that the ray can bounce into it, right? Any ray you pick is going to bounce into this. So the middle line that contains the vertex and the center will also contain the focal points. So now the focal points are, the distance over here is 2, the distance over here is 2, and then I need to add another root 13 and take away root 13 so that I can get into these focal points that I'm just going to put like that. So what are my focal points? Everything is happening at 3, right? Because the x is equal to 3 for all 5 of these points, right? You have 1, 2, 3, 4, 5 important points lined up on this one line. 2 focal points, 2 vertex, and the center, right? So 5 important points. All of them have the same x-coordinate. They're all, in this case, at 3. Now, I need to go to the center and pick up the y value for the center, and that is 1. Then I have to go 2 units out, right, to 3, so plus 2 units, and then plus square root of 13, and that will give me 3 plus root 13. You can get decimals if you care. And that would be the, let's call this one F1. Now F2, the one on the bottom, also has 3. But now we are starting at 1. We are subtracting 2. And then we are subtracting root 13. Because you have to go downwards. So your location is at 1. That's where you start for y value. Then you go 2 units down to get into the vertex, so minus 2. And then you can see that the vertex is at minus 1 because 1 minus 2 is minus 1, which is the y value of the black point here, which is a vertex. And then you are subtracting negative 13, which is that c, which we calculated. So this becomes now negative 1 minus root 13. So those are the points, the coordinates for our focal points, the foci. And finally, calculation for these asymptotes. So I do have a point of 3, 3, 1, which is the center, and now I need the point in the upper, let's say, right corner, which would be 6, 3, right? Because we had an x coordinate to be 3, and then we went 3 to the right, so 3 plus 3 is 6 for x, and then y coordinate is the coordinate of the vertex, which is a 3 on top. So 6, 3. And now just use your standard slope formula, 3 minus 1 divided by 6 minus 3, which is 2 over 3, so 2/3. And then you can use that x is 3 and y is 1 to actually come up with a line. So y is equal to mx plus b. Plug everything in. Y is 1. M, slope, is 2/3. X is 3 plus the unknown b. So b is negative 1. Can we see that in there? Yeah, we can kind of see. I missed it here, but it's -1. So one of the asymptotes, it's y equals 2/3 x minus 1. That's the asymptote. We can call it line 1. And now you have your line 2. Now you can also, right, you don't have to compute these things. If you're good with counting, you can have, as you can see over here, 2 down, 3 over. So that's your slope, -2/3. Remember, rise over run. So I don't have to compute it, I can just count it. So for the line 2, the asymptote 2, we already have -2/3 x because the slope is negative, right? It's dropping, and it's 2 over 3 to get anywhere on that line. Now your y-intercept b is available, it's a 3. So if you actually do the slope, you will, and everything, you will find that that's a 3. So with this calculation, I think we have everything. We have the center, we have the focal point, we have the vertex. I did not write vertex. I guess I should. Vertex. One vertex. Let's do the top one first because that's what F1 and L1 are on top. Vertex would be 3, 3. And the second vertex would be 3, -1. 3, -1. So there are your 5 important points. And as I said, they all line up on the same line every time, whether it's horizontal or vertical. And in addition to that, we got the asymptotes. I can bet that a couple of your problems will have this way. Cool. That's the hyperbola. Horizontal, vertical. You will be asked to match them with the equation and to do all of these cool things. I hope you will deal with the homework quickly so that you can ask questions next time. Are there any questions now dealing with hyperbola at this stage before homework? All right. So in that case, we'll be back with 9.3 on the parabola.